Hello, good day everyone. In this video, I'm going to discuss one probability question that deals with normal distribution. So let me begin by reading the question out for you. The mass of a bag of flour in kg is normally distributed with a mean of mu kg and a standard deviation of sigma kg. If 97.5% of the bags of flour have masses less than 50.1 kg and 88.49% have masses more than 34.3 kg, find the value of mu and sigma. So, first step, we need to write down all the information given in the question into equations. So, the first equation will be probability of x being less than 50.1 kg is equivalent to 0.975. So how do I get the 0.975 is that it is coming from the percentage. Please take note, whenever percentage is given, it must be converted into probability by dividing with the number 100. The second information from the question is probability of x being greater than 34.3 kg, and that probability is 0.8849. So likewise, I have taken the percentage divide by 100 to convert it to become probability. So the basic thing that you need to know here is that any standard score, to find any standard score, we have to take the variable x that is given in the question and must be subtracted with the mean and divided by the standard deviation. In this question, we have two x values. Basically, 50.1 will serve as the first x1 and 34.3 will be the x2. So, in order to make things clear, I'm going to use m as the z value. So, m1 will be x1 minus mu over standard deviation, and my m2 will be x2 minus mu over standard deviation. Okay. So in the first case, as I convert probability of x less than 50.1, I'm going to rewrite into the standardized form. It is going to be z less than m1 because the x has been converted to z. So this value also must be converted to z. And this one represented by 0.975. Likewise, the second information, probability of x greater than 34.3, will be represented by probability z greater than m2, which is equivalent to 0.8849. So here the x has been converted to z, and then this value is also converted to the corresponding m2 because it is converted using this formula. So instead of putting another z and another z in these locations, I will put M1 and M2 to make things clear. You also can put Z1 and Z2. This one has no problem, but it is all up to personal choices. So let's continue from here. So we have two statements here. The first statement, which is this one, and then we have the second statement, which is this one. So after this, how we going to continue is all depends on the explanation that I'm showing you here. Okay, so there are four scenarios that can happen whenever we have a statement like what I showed earlier. So if you observe the statement number one here, we have probability z more than m equivalent to a certain a value. The a is the probability, which is also the area under the bell graph. And if this area is more than 0.5, so please take note, you have to check for two information. One is the sign of the inequality. It is more than. Okay, probability z more than m, and the area is also bigger than 0.5. So your graph should look like this. And very importantly, your m must be negative. Why your m must be negative is that it is because at the center is always 0. At the center is always 0, and whatever to the left is negative and whatever to the right is positive. So how to know the perfect position of m, whether it is on the left hand side or on the right hand side? You have to check for the inequality symbol here and the inequality symbol of the area, whether the area is more than 0.5 or less than 0.5. So let's go back to our initial statement, which you can see on the screen. Here the symbol is less than and the area is definitely more than 0.5. 0.975, this value is definitely more than 0.5. So we have to look for this combination. So if we go back to all the four combination, we have the less than and area more than. So your sketch must look something like what is shown here. Please take note of that. And in this case, your M must be positive because your M is on the right hand side. So as you can see from this information here, the area is 0.975. So as I represent this here, this area, the yellow area is 0.975. So automatically we can take this area, the unshaded area, which is I'm shading with the purple color right now, will be 0.025. How do I get this value? The entire area under the graph is 0.975. So what I did 1 minus 0.975, I get 0.025. So this is the value that you need to find in the table. Please take note, this is not a Z value, this is an area value. So when you're finding for area value, you cannot go and look for the values here in this column or this column. That will be wrong concept. Please do not do that. Since this is area, your focus must be here only as indicated in the yellow box. So you have to find whichever area value given to you in this highlighted area only. So now in this highlighted area, we are looking for 0.025. 0.025. I think the closest value, yes, we have a perfect value here, 0.025, which is corresponding to 1.9 and 6 here. So definitely the M value here will be 1.96. It's going to be M equals to 1.96. So I can update into my calculation. My M1, from here I got to know my M1 is 1.96. So next we move on to the second statement. Here we have the statement more than and more than. Please take note. So and then the area is more than 0.5. So it's more than and more than. So let's see in the chart, we need both more than. So I think we are coming back to situation number 1, where the area, the M value must be negative. Okay, please take note, more than and more than it here and also here. So with that, we're gonna sketch. We're gonna show some sketches here. So this area here is 0.8849. So let me double confirm this value. Yes, 0.8849. So automatically this small area here to the right must be 1 minus 0.8849, which will give you 0.1151. But unfortunately, in exam, when you use the distribution table, the table will only give you the areas to the right of any specific Z value. So this area is to the left of the Z value. The Z value in this case is M. So it is to the left. So we cannot directly use the table. So I need to further modify this distribution graph into a mirrored version. That means you go and reflect the graph into the right hand side where you put the M here, and this small area will be again the same value, which is 0.1151. Please take note of that. So if this is 0.1151, now I can use the table to get the M value. So what will be the M value right now? So let us go and find for 0.1151. Where is it? Do you find anything closer to 0.1151? Yes, I have a perfect combination, 0.1151. So it is corresponding to 1.20. So let me update here. My M value will be 1.20. Please take note, our original graph was like this, in which we already know M is negative. So you cannot say your M is 1.20. You have to mention is negative 1.20. This is the ultimate careless mistake you need to avoid during examination, and please update your working accordingly. So your M2 will be negative 1.20. So please take this M1 and M2 and put into these equations here. Please put into these equations here in order to solve for sigma, which is the mean, and which is the standard deviation and mean. So let me do that for you. X1, my X1 is 50.1 minus the mean over standard deviation is equivalent to M1, which is 1.96. So this will be my first equation. And my second X2 will be 34.3 minus the mean over standard deviation is equivalent to negative 1.20. This will be my second equation. Do simultaneous linear equation, solve for mean and then standard deviation. So your mean will be 40.3 as you do the solution, and your standard deviation will be 5. As simple as that, boys and girls. So you can just revisit the entire video. If you have any question, you may post a comment under the comment section. I'll provide my explanation.